So hi, my name is Rae Krantz. I work for a company called Tollwave. They are out of Phoenix. I live in Akron, so I work remotely. It's new. I've only been doing it like 3 or 4 months, but it's awesome. I love it. The company and the remote thing. And the idea for this talk came from my propensity to always ask why. Oh, why does that thing work that way? Why does it do the thing that it does? Why do so many people hate this language? And so that's where this came from. And I got the idea for it as season 7 was wrapping up with Game of Thrones. So there's going to be some stuff in there. I don't know if you read the thing on Meetup. There are some pictures on slides that aren't necessarily spoilers by themselves. But if you've seen like 2 seasons and haven't finished and are worried about that, you might be in dangerous territory. There will be more spoilers at the very end, but it's only like 2 minutes of spoilers. You can leave and come back if you so desire. So that's that. But yeah, so the purpose of this talk is to give just very high-level broad strokes of why was a language created, what did the inventors, if you will, the writers of the language have in mind, how is it used in, how does it reflect its origins, basically. And the languages we're looking at are Ruby, Python, Go. Wait, hold on. Ruby, Python, Go, Erlang, Clojure, and JavaScript. Ruby, Python, and JavaScript I've all used. Erlang, I did a kata in it once. And I worked at an Erlang shop, so I was at least surrounded by a whole bunch of Erlang heads. And then Go and Clojure, I just had heard about them and thought they were cool and wanted to know more. And there are some languages that didn't make the list because you only have so much time in your life and the day. But we'll get to that closer to the end. Anyway, so here we go. So a few concepts before we get going that we're gonna compare kind of across the languages how they handle a couple different things. And I want to introduce these up front because if you did not study computer science in undergrad, you might not know specifically what some of these terms are. Or even if you did and it was 10 years ago, 20, whatever, and you don't actually use it day to day, a little bit of a refresher. So the first concept is something called the diamond problem. And this is something, pictures from Wikipedia. This is how different languages handle multiple inheritance. So as you can see, you have class A and then class B and C both pull in A and redefine a method in a certain way but different. And then class D comes in and pulls in B and C and pulls in that same method, right? That method that B and C have both overwritten. Well, now what does class D use? Which implementation of that same named method, does D use? So that's the diamond problem. And different languages solve that in different ways. And then another thing that was confusing specifically for me, again, not coming from computer science, is linked lists and arrays and how they handle memory allocation. And this is confusing because a lot of languages, or by a lot I mean like your Rubys and your Pythons, they kind of mesh them together and they call it an array or they call it a list, but it's not really either one. So the best explanation I've gotten of the differences between these is from a blog series from Vaidehi Joshi called BaseCS, and this is a picture she drew, which is very helpful. So the main difference between arrays and linked lists are an array is sequential, so you can access items in the array by index. And a linked list is not sequential, so each item in the linked list has a pointer to the next item in the list. So if you want to find item 5, you have to start at 1, go to 2, go to 3, go to 4, go to 5, right? Whereas in an array, you can just say, oh, hey, give me item 5. And this has different ramifications for like adding data, like a linked list. You can add to the front, but like adding in the middle is going to be a pain and a half. And the other thing about this too is that arrays, like because they take a set block of memory, if you're adding and subtracting or changing up arrays, you actually have to create a whole new array every time you add or take away an item from an array. I did not know that because it does not seem like it's doing that. Like Ruby just says, hey, unshift, ta-da, your array changed, but it didn't. It actually, well, in some cases, we'll get into that in a second, but it might have had to make a whole new array to get there. And then another thing, locks and thread syncing. So a lock is if you have different concurrent threads accessing the same object, you don't, if B depends on changes that A is making to this object, you want to make sure B doesn't access the object before A changes it. So you would put a lock on the object and not let B in until A is done. So that's kind of what a lock is in terms of like concurrency and threads and stuff. So those are a few things that will crop up throughout the thing, and like to clear that up. So we're going to start with Ruby. This is probably one of the languages I have the most experience in, Ruby and JavaScript. So that's why we're starting here. So Ruby is actually, it's very friendly. At least the founder of Ruby, he wanted to make a language that was very friendly. And there's actually a kind of mantra in the Ruby community that's like, Mats is friendly, so we are friendly. It's kind of his ethos, right? And he has several quotes here. One is, he wanted a language with the principle of least surprise. He didn't want any gotchas. He wanted to make Ruby, quote, natural, not simple. So Ruby can get complicated, and that's because he wanted it to be as open-ended as possible and give developers the freedom to do whatever they wanted. And that can, of course, introduce frustrations, right? Because there is maybe more variability than some people might want, but that's what Mats wanted. And another quote here, he said, I wanted a scripting language that was more powerful than Perl and more object-oriented than Python 2. And so he made everything an object. Easy way to solve that. So every bit of information in code in Ruby has its own properties and actions. And that's how that plays out. One practical way this plays out is Ruby doesn't have decrementers or incrementers because these only affect variables, and Ruby does not have variables. Ruby only has objects. So you can do like plus equals and minus equals, but you can't use these variable operators, which is funny. I didn't realize that, like even using Ruby, and then I was like, oh yeah, I've never used those in Ruby code. Good point. And how Ruby solves the diamond problem is single inheritance. Get it? Only inheriting from one family? Yeah. So instead of, they're like, okay, well, if you have a problem when you inherit from two different classes, let's say you can only inherit from one class. Done. Problem solved. Super easy until you realize the negative side of that, which is one of Ruby's weaknesses, monkey patching. And this is a sore spot for me. I was scarred for life with regards to monkey patching. I don't know, about a year ago. So since then, I'm like, oh, Ruby, you're not as innocent as you look. Basically, monkey patching just allows you to, following single inheritance, you can completely overwrite and rewrite a class. You're not extending, or a method within a class. You're not extending it, you're not adding on to it, you're replacing it completely, wiping it out. And this is really useful if you have a gem and you say there's a Rails gem, and it's great, except there's this one thing that it sucks at, and so you make a whole new gem, and you overwrite that, and you just overwrite that method. You write it the way that it should be, and that's wonderful, and you ship it out to all your open source people, and everyone loves you until the Rails gem updates, and you don't. And so now the Rails gem, maybe it changes some of the stuff that you're pulling in that method, right? But you haven't updated your method to handle all that new stuff. And then it gets really, really frustrating and annoying to track down. So this is a very commonly known problem in the Ruby community. But again, it's one of the byproducts of, hey, here's a kind of a construct, and you can change stuff however you want. So some people do. And then this, so this falls into kind of that flexibility of Ruby that Mats wanted. He tries not to restrict the coder, is kind of a common thing he said. And a common thing you'll hear Ruby developers say is, I love Ruby because it's fun. Ruby made coding fun again. And that was Mats' goal. So he did that. So how Ruby handles arrays, again, Ruby's handling of arrays is a combination of linked lists and arrays. And because you can, shift and unshift, end, beginning, you can access by index, all of that. But one of the ways that Mats got around, or tried to kind of allow for that memory allocation, is Ruby behind the scenes allocates memory to an array, allocates more memory than you ask for in an array. So if you instantiate an array and it has one object, or one item in it, Ruby gives you 3 spots. Anyway, it's like, oh, you have an array, I assume you're gonna add stuff to it, so we're gonna give you more room. And then if you go above 3, then it gives you an array with 20 spots. Now you think, oh, I've only got 12, cool, maybe you add 4 more things, and guess what? You haven't had to reallocate memory yet, because you actually had 20 spots behind the scenes in Ruby. So that's one way it tries to to allow for that memory management there, which, oh, it's cool. I like it. And then this is just a fun little thing of Ruby that I just threw in here because I like it. When you're iterating over an object or array, what have you, rather than, you can do a for loop, they have it, but people in Ruby like to use .each because it makes sense and it's prettier and cooler. I don't know. Ruby's also really into like easy to read, right? Like common English. So even things like parentheses are optional, right? Like around your, I don't think I have a slide for this. Oh yeah, that's the segue. But even parentheses are optional. And so there was one developer, an old coworker, he said he didn't like to use parentheses around his like variables that you're passing into a method or anything like that. And he's like, it's because I want Ruby to read like a sentence. And if you have parentheses breaking everything up, then it interrupts the flow. Again, I like my parentheses. I think I like to know where my variables are, and we can both code Ruby in the way that works for us. So good and bad. It's great because I get to do what I want, but it's not great because then I have to read his code. So anyway, so a lot of flexibility. So moving on, evergreen tweet here. Pythonists are all explicit is better than implicit, and Ruby is like, look, I'm making a bong out of a hairdryer. And so this speaks to Ruby saying, hey, make stuff. Like, here's a sort of framework language. It's still a language. Whereas Python is more, hey, I want to accomplish these things. So getting into Python. Oh, I forgot to mention, a couple companies that use Ruby are Cover My Meds, which is actually in Columbus, Ohio. And then Stitch Fix uses Rails, and Living Social definitely did for a while. I assume they're still on it also. So I want to throw those in for like real life application. And then so moving on to Python, Instagram, of course, was on it. They did a whole big thing like migrating from Python 2.7 to 3, National Weather Center, and then Civ 4. So like Python is awesome because Civ is awesome. So the founder of Python, Guido, he did name it after Monty Python, the rumors are true. And he said he wanted to have a better way to do system administration that was not writing C programs or boring shell scripts. And kind of a fun little thing about this is like that is a big piece of what Python is used for. Like Python and Ruby have very similar scripting capabilities, right? But most like, DevOps era people or world people, like you write your Python scripts. And so I think it's interesting that, that's why the language was created and that is why people use it. So that was kind of cool. Error handling was important to him. And he was frustrated by the lack of extensibility in languages he was using. So he wanted a language that was more extensible. And now Python has a, what's it called? The Zen of Python. It's like their mantra. And there are a lot of things in it. One of it is beautiful is better than ugly. So as you can see, its syntax is very pretty. It's very nice. There's no random like commas or quotation marks, or there's no more parentheses than you need, but no fewer. You got your nice little separation. Like it's all very clean. And the only way that that Python knows that this return statement is part of the function is because of the indentation. If the indentation was not there, the return statement is no longer part of the function. So it's like, you kind of, again, there's a few more rules, so to speak, in Python, but it's because it values things like beauty and simplicity, and it wants things to be clear. And readability counts. It's another one of the mantra. Python also has a lists and tuples, and this is how they manage arrays / and/or linked lists. So lists are what you would think of as arrays in a lot of other languages, and the only difference, well, both of these are, the difference is, lists are mutable and tuples are not. So that's the difference. And this is where I feel like Python kind of breaks its own code a little bit, because so lists are, let's see, how does it go? Yeah, lists are best for homogeneous data and tuples are not. But that's not like enforced. It's like best practice that's how Python developers use them, but it's not required. And I thought, you left a little loophole there. Like I expected there to be rules around that, and there wasn't. But then there are some libraries like NumPy enforces homogeneity in lists. So some of the libraries that extend it do, but Python itself leaves that slightly open. So dictionaries are where Python maybe starts to make people frustrated, which we'll get to on the next slide. But dictionaries are what you would think of, like if you're in Ruby, a hash, or if you're in JavaScript, an object, right? Like key value pairs. So that's what a dictionary is. And the keys themselves have to be immutable data types. And that's to encourage quick lookups. So a tuple could be used as a key in a dictionary because they're immutable. And where this frustrates people a little bit is that Python actually does not have case and switch statements. And it's because there have been several proposals to like the Python deciding code body over the years of how to implement case switch statements, and they've all been turned down. A very common reason is, oh, that's ugly. Like that's an ugly implementation. Again, going back to that, Zen of Python, we're not going to add this like kind of convoluted solution that's not efficient and it's not pretty. But another, I think I have it on the next, no, I don't. Oh, I just have the quote in here. Oh, yeah. So one of the quotes from one of the Python core developers is that why do we need, let's see, without having a way to declare named constants, there's no way to generate an efficient jump table, right? So all we would be left with is syntactic sugar for something we could already do with if-else chains or dictionaries. So in Python, if you want to do like a case switch, people usually just implement a dictionary and do the lookups that way. Sparse is better than dense, right? Like, hey, we have a thing that does that. Why re-implement it just so we can call it a name that people are familiar with? We already have a way to do the thing. Let's not add more cruft on top. So, some people get upset, but they have their reasons, right? That's why. And then a cool thing of Python is args and kwargs, which is just fun to say. And that's where a function can accept a variable number of arguments, right? This is in a few other languages. It's not necessarily exclusive to Python, but the kwargs implementation of it is a bit unique in that. So arguments are just your standard array of arguments, right? And then kwargs would be named arguments, so something like a key value pair. So you would return, you could return like fruit equals apple instead of apple at index 0, or what have you. So you can kind of work with it that way. It's neat. The big place where Python shines is science. So it supports array programming through NumPy, and the reason why, I think one of the main reasons why Python really took off in the scientific community is because it was all kind of a timing thing, right? So again, Python and Ruby have similar like powers, if you will, similar abilities, but Python's the go-to. Python's what you do. If you're a developer, you want to get into machine learning, you want to get into data science, you use Python, and it's kind of all NumPy's fault. Like NumPy came around as the data science boom was kind of getting its start, and then like, oh, well, NumPy is awesome and huge, and let's do more things, and now Python is this massive ecosystem of data science tools, and it's because they got started first, basically. But it has a massive ecosystem of data science tools, so use it for what you will. And I have no like scientific basis for this theory, but I also kind of wonder if like the Python mindset kind of also appeals to the more academic mindset, like people who are coming into the scientific or from the scientific community or had kind of that like research-based ideas. They're like, no, I want my functions to be strongly defined, and I want things to have like more structure. I want to be able to have immutable, lists if I want them. Like, I don't know, I just wonder, it's like more kind of that academic safety net kind of thing, rather than, hey, everything's an object and do stuff. So, I don't know, personal theory. So everything is first class, though, in Python. And this is a quote by Guido, the founder. One of my goals for Python was to make it so that all objects have equal status. That is, they can be assigned to variables, placed in lists, stored in dictionaries, parsed as arguments, and so forth. So that's cool. It's a common thing in languages, but I think it reflects some of Python's personality here, too. Oh, another thing that Python does not have is a multi-line comment, because, again, that thing, hey, we have a thing and it works, so we're not going to make a new thing that does the same thing, is basically what Guido is saying here. It's like you can use multi-line strings as comments. Unless they're used as doc strings, they generate no code, so there, use that. Kind of the same thing of like, hey, you have a dictionary you can use for lookups, we're not going to do case switch. You're fine, you're good. And people get mad, but what are you going to do? you didn't write a language. So one place where Python is starting to, I guess, lose support, if you will, is when performance really matters. And I mean, it's just because everything, we have so much more data now. It used to be one of the leaders, right? But now as more data, more concurrency is needed, it's falling back. And Stream is a company that streams stuff. And they wrote a blog post on their switch from Python to Go. And their reason for it was they said Python is a great language, but its performance is sluggish for use cases such as serialization, deserialization, ranking, and aggregation. So they still use Python for a lot of their data analysis, but in terms of pulling that in and kind of sorting it, they have switched to, Go. So Go was founded by a bunch of people at Google. Oh, and let's see, companies that use Go, besides Google, are Atlassian, the Reddit AMA, and DigitalOcean uses it for their services. So those are a few examples. And the main motivation for Go was something that was easy to build, simple, reliable, and efficient software. So seems like a simple enough goal. So these guys are the writers of the language. Their values, or their main values, whatever, important things, were concurrency, speed, something that was lightweight, something that was easy to write, and they wanted to fix the problems of all the other languages but maintain the good stuff. When I read that part, I just laughed, which you can't really see, but yeah, it's like, oh good, no one's ever had that idea. Let's fix the problems that are in other languages, but keep all the good stuff. But I won't be too hard on them because they did a pretty good job at it. And some people write Mott's in Ruby. His goal wasn't actually, I want to make a language that's perfect. It was, I want to make a language that's fun. So there is, I'll allow it. You're allowed to try to make a perfect language. So the thing that Go is most known for is a Go routine, and that is just a fancy word for how they handle concurrent threads. And how you create a concurrent or a thread in Go is as simple as adding Go onto your function, and hooray, now you have a thread in Go. Go is also referred to as Golang. So if I say Golang sometimes, that's what I mean. And that's, I think, mainly for ease of searchability. If you search Go on the internet, you're not going to get very many places. Ironically, maybe. So yes, let's see. Oh, this was one of the reasons Stream switched to it is it's especially good at large code bases worked on by many engineers coordinating only loosely. Again, you can see the Google influence there. Oh, yeah, kind of a large code base, kind of a lot of engineers. And then Stream, again, that company that switched over, they saw rapid onboarding was really easy. It was really, not many people know Go, but it was really easy to get people onboarded into it and being productive in it quickly. And that was also another one of the motivations of the language. So a thing that it uses, or Go uses, is channels. Channels are the pipes that connect concurrent Go routines. And you can send values into channels, let's see, from one Go routine and then receive those values into another Go routine. By default, this is how they handle kind of locks and stuff. By default, sends and receives block until both the sender and the receiver are ready. So if the sender's like, hey, my data's not ready, then, then it won't. So there you go. And so you can use channels then to synchronize actions across Go routines because you have these kind of blocks and stuff already in place and working that you can set. So Go actually has real arrays in that they fix the size of the array at compile time. And slices then are what we might know as the commonly used array, which are the things that you can append and slice from and append stuff to and that kind of stuff. So arrays are accurately named, props for that. And then slices are built on top of arrays and are multi-dimensional. And from the Go blog, they say, to increase the capacity of a slice, one must create a new, larger slice and copy the contents of the original slice into it. So they're sort of making you do the legwork of what some languages kind of handle for you and hide from you. But Go kind of makes you aware of the work that's going into your stuff because a feature or a goal of Go is to be lightweight. And so they don't want to be doing any extra work for you that you don't want done as well. And then maps are a hash table, or they implement a hash table. They're a dynamically growable associative array, which makes perfect sense as a phrase. And you can, they have a length property. You can delete stuff from them. So that's kind of how Go handles stuff. But I like that they actually have an array that's an actual array, and then they build array things we know as arrays on top of that. So I really like that. What did I do? Oh, OK. And then another thing so there's a lot going on here. So this is declaring a variable, or yeah, sort of, mostly. So the I is the variable that is being assigned to the value, right, whatever M route is outputting. And then the OK is you telling Go, I expect this to succeed. And where that becomes useful is you can actually expect an error back from something, right? So you can say, OK, I expect this to succeed. If it doesn't, that's a problem, let me know. But you can also say, hey, I expect this to error out. And so if it's errors, like that's fine, keep going. Like we wanted that to happen. And then if you don't care about the variable at all, you can just use an underscore, and Go throws it away. And that plays into how Go tries to stay lightweight, memory management. It makes heavy use of variables. Variables don't matter sometimes, and so you just use underscores, and then you don't have to like keep those in memory. And you can run your I don't know, algorithms, calculations, whatever, and maybe you only care if it returns OK or an error, so you watch for that, but you don't care what value it returns. Right. And another thing it does, which is a bit unique, functions have named return values and also implicit returns. So in here, we're assigning our variable a to 3, and then we're returning the function, and the function now knows, oh, hey, I'm going to return all of the named variables in the function. Those are what I'm returning. So it's actually going to return a and b here, because those were both named within the function. So it's like a way to be efficient and stuff. Now, obviously, recommended, maybe don't do this if you have like a 30-line function. But with shorter functions, it also makes it a little bit more readable, right? It's like, oh, I have these 5 things I've assigned stuff to. Oh, and now I'm returning. I'm done. So I have all this stuff. So that is one thing it does. And Go, in an effort to, Go is a bit structured. And I found the syntax and stuff very similar to Python, at least in that it's more structured. So it puts hedges around its developers, so to speak. So you cannot compile, or Go will not compile, if you don't use all the packages you've imported. So again, keep it lightweight. We're not going to have all this extra cruft. Someone tell NPM how to like make that happen. So that's pretty cool. And then the Go language uses a formatter. And when you save your file, it formats all your code for you, and it formats it using tabs. And I believe it's even 4 spaced tabs. So I'm sure people have opinions on that. But so does Go. And if you're going to use Go, you have to do it their way. I guess just a way to be like consistent and kind of a layer up. Don't get bogged down in stupid debates, right? It's like, all right, let's solve this one and talk about stuff that matters. So a couple weaknesses of Go. It's a relatively new language. Relatively, very relatively. It's been around for several years. But so this is from a survey on Go's website. And basically, as you can see, most people wish it had more dependency package management. Kind of where that comes in. And that's just because, I mean, the ecosystem around Go is growing, but it's just not as large as some of the other languages who have been around a bit longer, right? So that's that. And yeah, so that's Go. But if you find yourself wanting more concurrency, that's my fun segue into Erlang. So Erlang is neat. I like it. Its syntax is quite different from your Go's, your Pythons. It was founded by those guys. They worked at a company called Ericsson, which is a telecom company. And so it was kind of uniquely developed to address the issues that telecom companies face. So its main foundation was a failure in one component should not affect the whole system. Like something should be able to fail and get swept away and replaced, and everything else keeps running, right? Because you're never going to have 100% success in your telecom infrastructure. Something's going to fail, and you have to be able to handle that. So it assumes stuff will break, it handles that, so handle unexpected errors, never stop running, right? And companies that use it are WhatsApp, Ericsson, of course, which are where these guys work, and CouchDB. So those are some things. So what was the Java thing was write once, run anywhere. I mean, that was like the Java quote. Joe Armstrong, who's at least the most vocal Erlang developer, he's the one I always see at conferences and stuff. He said, Erlang is write once, run forever. And that's what it wants to do, like this guy. That's all I'll say. So yeah, messages keep on sending. Processes have unique names. And every variable is immutable. Values are copied between Erlang processes. So the memory referenced in a process is almost always completely isolated. That makes sense. Processes communicate using message passing instead of shared variables, which removes the need for explicit locks. And then after a process receives a message, it decides what code to run based on the message, but it doesn't have to be explicitly declared in the message. So it kind of it has the information it needs, and then when it gets the message, it knows what to do with that information, but it doesn't depend on the message to deliver any of the information that it needs to do the thing. So it's kind of cool. So let's see. This is a quote from Erlang's docs, I think. So concurrency supports the primary method of error handling in Erlang. When a process crashes, it neatly exits and sends a message to the controlling process, which can then take an action. For instance, starting a new process that takes over the old process. So like if a telecom server dies, something else dies, you got to keep running, your phones have to stay on. So you need someone to come in and say, oh, nope, now I'm this thing. Cool, everyone talk to me now instead. And just sort of insert itself into the process. So that's something that Erlang is built for. Lightweight processes are key here, similar to Go. But the idea is that if a process zombifies, it doesn't infect all the other processes. It just is like, oh, now you're buried in the basement. We don't have to worry about you. And we're going to create someone new or bring someone else in. Erlang is about handling for what you know and knowing what you want and saying what you want and then handling for those cases. So it doesn't, it's dynamically strongly typed, and it has, let's see, they have type checking guards like this rather than like, so in JavaScript, you know, you can, oh, what is type of this thing and does it equal this type that I'm expecting and yada yada. This just declares it straight in the guard. It's like, hey, I want this thing to be this thing, and I expect there to be, you know, one thing that's a Boolean. Cool. Let's keep going with this. And it's also unique to me in that its functions, they can be named theoretically the same thing, right? This looks like the same function with just a variable number of arguments, right? Except it's not. These are completely different functions because arity matters. So this can get fun actually when you're having to deal with errors, because it might say, hey, you passed your sum function, one argument, and everything broke. What are you doing? You're like, I don't know, it needed 1, I passed it 1. Well, unbeknownst to you, you should have passed it 2, and you just like called the wrong thing. So it can get fun, but it's also, I mean, again, it's like highly specific. Handle for what you want, and you know, if you receive an error, then you feed it into where it needs to go, theoretically. But keep going. And this is my favorite thing about Erlang, which is it's kind of built-in if-else, if you will, the head-tail recursion stuff. Or wait, that's the next slide. This is just built-in if-else. If-else, right? So if you run an expression through this function, every time x is true, it'll run this on your, I don't know, object, whatever. And then whenever x is no longer true and you hit, oh, but the y case is true, cool, we're going to run this expression until, oh wait, now we don't have any handlers, so now the final expression we're going to run is this one. So I like it. I think it's clean and it makes sense and it's easy. Like again, I haven't done a lot of programming in Erlang, but it didn't take long to catch on to kind of this pattern. Head-tail recursion. This is where I was going. So Erlang is a very fun recursive language by nature. Never thought I would say fun recursive in the same sentence, but it is. So it implements head-tail recursion. maybe should have mentioned this at the beginning. It's kind of one of those concepts, but it's a similar pattern, right? So you have your, let's say, array of stuff, and you take the head, the first item in the array, and you run your thing on it, your expression on it, and then you get rid of it. And now you have your new array, which is the tail, and you pass it back through, but now you have a different head. You take that head off, run the thing, get rid of it, and then run the tail again. And it's just fun, trust me. Go do a kata. So I don't know, it's really cool. I like that aspect of it. And there's no return statement, right? You don't have to say return because where we saw that underscore handling the final case of whatever you're trying to do, and then you're done. And it knows you're done, and that's where it ends. So that's where it is. So the last expression executed gives you the return value of the function. But if you want even more concurrency, let's see, I had a couple other notes. Oh, these are just differences. So in Erlang, processes do not share memory directly, but instead copy data between threads. In Go routines pass references of the data to each other. But what if you wanted a language whose core data structures were immutable so they could be shared readily between threads, right? Because we're not getting that. So in Erlang, you're not sharing your data between threads. In Go, you're like passing the references of the data. But this language says everything's immutable, so we can pass it wherever the heck we want because it's not going to change. So companies that use Clojure are Capital One and Spotify, for a couple big name ones. And the guy who founded it, he wanted something that was robust, practical, and fast, and he wanted multi-threading. And these were kind of his qualifications for it, I guess. He wanted it to be a Lisp-based language. He wanted it to be for functional programming. He wanted it to be connected with an established platform. So Clojure is built on the JVM. And he wanted it designed for concurrency. And I gotta hand it to this guy. I like Clojure. It's really cool. So he did okay. So he combined JVM and Lisp and then built Clojure on top of those things. So it inherits a lot from JVM's ecosystem, Java's ecosystem. And so there are some things like the date construct. Clojure doesn't have its own. You just use Java's. So it kind of eliminates the need to build some stuff on its own because it can depend on JVM capabilities when needed. And then it implements maps, sets, and vectors as first-class citizens. And then, it makes use of linked lists and arrays, which we'll get to. So a little bit about the syntax, because this is very different. Well, it's Lisp-based, and none of the other languages are Lisp-based, so it's very different, at least from all the other languages we've looked at. So everything between the two parentheses is a self-contained expression. And the first item is the function or macro to call, and the second item are the arguments. So that's kind of the order. So it's almost like a Yoda way of programming, maybe. And then the thing that is the coolest to me, because I love efficiency, and Clojure loves efficiency, so I should code in Clojure more. But Clojure likes to do things in the most efficient way possible. So this is, let's see, I sometimes get these confused. I think this is a vector and that's a list, yes. So vectors are in brackets, lists are in parentheses. Oh, and small note, this is not a typo. This is because, if y'all remember, everything within parentheses is an expression, but this is not, this is a list. So we just put this little tick there to say, oh, no, this is not an expression. Don't evaluate it as an expression. So that's what that's for. Anyway, back to what this is doing. So it's running conjoin on a vector and a list. I even have a thing, but I'm just going to put this down. And the thing that makes the most sense, performance-wise, when you're adding something to a vector is to add it to the end. So conjoin adds it to the end if it's a vector. And it's the opposite for a list, so it adds it to the front if it's a list. And Clojure makes that decision for you because it makes the most sense. And I like that. So you don't have to spend your time what would be the most performance, efficient way to do this thing? It does that for you. And yeah. So, and then it also has implicit returns with its functions and also let expressions. So this is going to return hello world. We don't have to tell it that. It knows. And this is another cool thing about Clojure. I don't know the real life applications of this one. And in my research, I couldn't find one. I found several blogs saying, yeah, so this is cool and this is how you can do it. I don't know when you would use this, but it's possible. So basically, this is a comparison of Clojure's thread first and thread last. The only difference is, whoops. Do I have a? No, I don't. It's okay, too fancy. The only difference is this is a single arrow and this is a double arrow. And the difference that it does is, it's sort of, you might be able to think of this a little bit like chaining, right? At least the thread first expression. So it's taking this and then it's making it the first argument in each thing. Or I guess, yeah, Clojure people might get upset of how I explain that, so I apologize. But, so as you can see here, it takes this and then it'll take the result of this and then pass it in, so it'll run the plus, action on this object and this object in that order and on down the line. And then, but if you do the thread last, then it puts it in the last place. So instead of running plus 0 onto 1, you would run plus 1 onto 0 and then plus 2 onto that result rather than, plus that result onto 2. Right, so it's sort of like a mirroring kind of thing. And yeah, I'm going to find a use for it. It's cool. But yeah, it's just a little Clojure-y thing, and it's neat. But the main the main weakness of Clojure, in my opinion, is it's list-based, right? So you've got all the parentheses in the world, and I can't even keep track of my parentheses and brackets in JavaScript, so heaven help me if I got into that. But hey, it's the price to pay for concurrency. And I'll re-emphasize the immutable data structures of Clojure, because that is kind of its big thing, and how it's able to keep thread communication fast and I don't know, I guess efficient, if you will, right? Because stuff is immutable, so you can't change it, so you don't have to worry if it gets changed or not. But if you want even more annoying punctuation, last but not least, we're going to talk about JavaScript. And the rumors are true. I don't know, is this on the, okay. This is a crazy, so we've all heard that it was written in what? What are the, is 2 weeks is what people say, or like a month or whatever? 10 days, that's absolutely true. What? How can you write a language in 10 days? So this guy, and you start to see why JavaScript has an identity crisis. Because, so Ike wanted a Lisp-inspired language because he really liked Lisp. So he started to write a Lisp-inspired language, and then Netscape, who was his employer, said, wait, no, we need to partner with the JVM because everyone loves Java right now, so it has to run on this thing. So it's also Java-inspired, but of course it has nothing to do with Java, and that's, people get them confused. So the man writes this thing in 10 days, and I think he used parts of his Lisp thing, but then also we all know what JavaScript looks like now. Whoops, sorry, oh my gosh. So anyway, and then he spent 6 months implementing it into Netscape. And now we are in this wide, wonderful world. And then there was a thing, so Netscape went to Sun to ask to use Java as part of their name because they wanted to build on the thing, or in the what's the word? Popularity of Java. Sun said yes, and then traded support for Java applets to run in the Netscape browser. So that's how we got Java applets in browsers, and Java in JavaScript, and yet no Java. And here we are. However, I will say, so I do Angular development now in my job, and TypeScript is trying to pull the Java into JavaScript, because now we have types, we have interfaces, we have all this stuff, and I'm like, that's so, we're not even supposed to be the same, but now it's pulling JavaScript back into Java, even though it was never technically part of it. It's all weird. Anyway, so JavaScript is not very opinionated, and Ike has a few explanations for this. I will give him the benefit of the doubt. So he says, I wanted to make a language for beginners where someone could just jump in and start building websites and it would be easy, so that's why there's no opinions. And I was like, or is it because you wrote it in 10 days? I don't know. But maybe it's a little bit of both, right? Let's see, he said, yeah, he wanted JavaScript to be, you could just write a little snippet, you could copy somebody else's, learn as you went, and you didn't have to know the whole language to use it. And that's still kind of true today, right? So lots of people do lots of things with JavaScript, and that's why we probably have 5 billion frameworks. But one of the things one of the obvious weaknesses of JavaScript is that it is too flexible. And Ike talks about this too. You know, there's no, like when you write a Python program, you don't necessarily have to worry what platform it's going to run on. I mean, you do, but not on the level of this, right? Because with JavaScript, you not only have to worry about what browser they're using, but you have to worry what OS that browser is based on. So there's a whole lot of room for flexibility, and there kind of has to be because browsers implement things in different ways. Case in point, I'm actually not going to use an Internet Explorer example. I'm going to use a Firefox example. So the way browsers handle things like floating point numbers varies. So if I figured this out when I had to work with currencies. Firefox does not let you keep trailing zeros after decimal points because you don't need them. They're not part of a number. Well, except if you're dealing with currencies, I want my trailing zeros. Now, Chrome and Internet Explorer do, but with Firefox, you have to trick it and, yeah, trick it. And it's funny, this was filed as a bug with Mozilla like a while ago, and Mozilla was like, no, it's not a bug. That's what a float is. Sorry, like we're not changing it. So they are technically correct though, right? And that's just different browsers have different opinions. And this is a fun fact about JavaScript is there's no sleep function, which again was one of those things that I never realized wasn't I use it in Ruby all the time, probably too much. And never realized I wasn't using it in JavaScript, but I wasn't, and it's because you can't tell if you tell JavaScript to sleep, the whole browser will just stop, right? Like JavaScript is one thread doing all this stuff, and you can't just stop it on a web page. So the purpose of JavaScript is to react and interact, and you can't shut it down. It never dies. So one of the token fun things about JavaScript is this, right? So I don't know if I should have looked that up. If triple equals was like added later to make up for the fact that the double equals is like a guesstimation kind of. So this is just showing there's like sort of equals and then there's absolutely equals in JavaScript. So 5 sort of equals a string of 5, but doesn't exactly equal a string of 5. These statements all return true. Should have made that more clear. But yeah, these statements all return true. And it's funny. I used to think, wow, JavaScript sucks. And everyone tells you, oh, just use triple equals all the time. But I've actually recently, like I'm working with these 2 data sets and they're using ID numbers, and the one is returning the ID numbers like in a string format and the other one is in a number format. And I'm like, actually, I just want them to sort of equals. Like, I want that. But of course it's in TypeScript, and TypeScript yells at you, and you can't actually implement it that way because it's trying to fix the problems of JavaScript. But I'm like, wait, but I want that. That's a good problem. So again, hey, flexibility. Just kind of hack it together, make it work. So all arrays are mutable. So you can do all the things to them, pop and shift and splice and slice and return a new array or edit the existing one or whatever. It's a big smorgasbord. And arrays are list-like objects whose prototype has methods to perform traversals and operations. I must have gotten that from like the docs. That's a very wordy way of saying what I just said. They're mutable. And let's see. Yeah, JavaScript arrays, they are not guaranteed to be dense. An array's length can change at any time. So they just kind of do their own thing. And objects are also mutable. So this is where, I don't know, JavaScript is and it isn't. So JavaScript is single-threaded, so you don't have to worry about locking. So objects can be mutable, right? It doesn't matter. Well, except now all these frameworks are coming out, and you got like Redux and NGRX and all these things that are like adding threads, sort of, at least async anyway, to JavaScript, and we're not going to talk about all those guys. But JavaScript by itself, objects are mutable because they don't have to worry about locking. And functions are first-class objects, which is not, again, not like super unique to JavaScript, but it kind of speaks back to that founding ethos of JavaScript, which is, you know, you can change functions. Remember, change functions, use anonymous functions, feed functions each other for breakfast. The world is kind of yours to make, and everything is kind of has this built-in flexibility to it. Yeah, so it's fun. And JavaScript also has this thing called Clojure, and I didn't include this the first time I gave this talk because Clojure it's something that I'm not even really going to try to explain. I just want you to know that it exists. It takes a while to like wrap your head around it. Basically, it's where an inner function still has access to outer function stuff, even when the outer function resolves. That probably doesn't make sense. I encourage you to go, oh, what's the book? You Don't Know JavaScript. He has a really good, relatively short explanation of what Clojure is. I only had to read it like 3 times to really get into it, but this is kind of a unique thing of JavaScript. And when I first heard about Clojure, the language, I was confused because there's also this Clojure, and then there's like Clojure.js that Google uses that is actually a compiles to JavaScript. It's their whole thing, and so they're all very different. But yeah, Clojure is, I think I get it. It's still there. So that was a lot. Honorable mentions to other languages that I'm just fascinated by, but it's life, right? We only have 5 billion things we all want to do. Rust is, of course, another one I wanted to look at. I know they do cool things with memory management, like they don't have garbage collection, roughly, I've heard, something. And they also have some interesting ways around the locking thing, which I was saying earlier. Do not do an internet search for Rust locks. It won't get you places. So that's a cool one. And then I know there's a ton of energy around Elixir, which is basically a Rubify. I have been told. Actually, the guy who tells me this a lot, I'll give him a mention, Jerry D'Antonio, who is very involved in the Ruby community and also a very proficient, experienced Erlang user. And so his explanation was always Elixir is like a Rubified version of Erlang. So if you want to use Erlang, but maybe your company, you have a bunch of Ruby devs, because Erlang's like kind of a rare skill. Elixir is Erlang, but in like Ruby syntax-ish. That's a very loose way of putting it. But if you want the power of Erlang with maybe more like, I don't know, Englishy function syntax, then take a look at Elixir. And that community I know has done a lot. They're starting to come up to speed, so to speak, with the level of like frameworky support and stuff that Erlang has. So it's taking off. And another one I want to look at is Kotlin, which is like JVME. Anyway, I'm not going to bore you with like all of my pipe dreams of languages I want to learn. But like there's a lot of cool stuff out there, right? So I don't know. I really like this stuff. And one thing I noticed is like all of these languages are written by guys, which is cool. Thanks, guys. But I want to write a language. So I wouldn't. It's funny because like, again, I sort of laughed at the Golang guys who were like, oh, we want to make a language that's perfect, has all good stuff and no bad stuff. And I laugh at them, but it is sort of a unique motivation because that wouldn't be my goal. Like I would, maybe find a specific problem that needed to be solved and go about solving it, which doesn't even necessarily have to be technical, right? Like Ruby's problem was, oh, I want to make programming fun. So like there are lots of reasons to make a language, and that's cool. So this is the spoiler alert section. We're going to have some spoilers. If you're worried about that, the next like 30 seconds are no go. No one's leaving, so we'll get going. So this is where I match languages to characters. And the thing that got me was when I learned that JavaScript was Lisp-inspired, loosely. I thought, I'm looking at all these languages, but the real king here is Lisp. It's in everything. I mean, but this could also be like C or Java, right? Because like Python's written on C, and then Clojure is on the JVM, and anyway. So I need to learn C too, because it's in everything. And then, so this was my first thought for Ruby. Don't worry, Ruby devs, this is not my final thought. I mean, it was just the obvious one. She's got an actual Ruby something, right? And she's magic. People talk about the magic of Ruby, but she's very like rigid, right? She's got like she doesn't smile. She does not have that much fun. So it's like, all right, who is like magic, but also fun? It's like the magic guy who likes to drink beer. Thoros. So I feel like Thoros and Ruby kind of go together. And then Python 2.7, you got your rules, you live by your rules. It's this guy. Say what you mean, follow the rules, or say what you mean what you say. And then Python 3 is just like him, but with dragons, which is the async stuff that all got added. And then Erlang, multi-threading, right? Like, you're in different places, sending messages, stuff. And JavaScript, who else but so many, many faces of JavaScript. There it is. All the frameworks. And then I think, are we coming up on the last slide? Speaker notes, show me. You're not showing me. That's all of them, right? Except for, oh wait, no, this one. So Clojure is like, what's their main thing? What's the word? Objects, immutable. Immutable objects, so like immutable honor, right? Immutable data structures, sorry. It's like she says something, she doesn't change. And then, for those of you who watched season 7, and you know just how important in Golang speed is and going fast, Go is season 7. So that's all I got, and I guess I can take questions. Yeah, thank you for having me.